Hello everybody, in this video we are going to continue our conversation about simplifying polynomials. In some of the previous videos we talked about what a polynomial is, how to know when to add and subtract two polynomials. So I'm going to show you real quick. Remember to always look in between the two parentheses to know if there's a plus or a minus there. So that automatically lets you know we're just adding and subtracting. Okay? And then we also talked about using the distributive property, something that we already know to multiply polynomials. Now we're more familiar with this one because we only have one term. And in the previous video we talked about how sometimes we have two parentheses and there's not a plus minus in the middle, so that automatically tells us we are using multiplication. Now just because there's two numbers in here, we do have to take each one of those numbers and multiply them by the other numbers in the parentheses. And that's no different than this -3 as well. Okay? So we talked about using the distributive property, which is using our arrows, multiplying, but I am going to show you a different method to organize your work. I actually like this method more than the distributive property because it keeps us organized and it allows us to focus on one thing at a time. So even though here we have the same kind of problem here, I'm going to show you how to use the box. So the first thing we're going to do if we're using the box method is to figure out how many terms are inside each parentheses, because that tells us what kind of box and how to create it. So this one has two terms. We have a 7p and a -2. There's two numbers here, so put a little 2 on the top. And then in the second parentheses we have the same thing. We have two terms, the 5p and the -7. So there I put another little 2 here. So when I create this box, it's going to be a 2 by 2. 2 rows, 2 columns. We need one for each term. Now the second thing I'm going to do once I create my box, it doesn't matter which one you put on which side, as long as the same parenthesis is on the same side. So I'm going to take this 7p and this -2, and I'm going to write 7p here, -2 here. So one box per term. And then I'm going to take this 5p -7 and I'm going to run it across the top. So I'm going to put the 5p on top of the first one and then the -7 on top of the second. So I'm going to reiterate one more thing because this one's important. Make sure that if the two terms belong to the same parentheses, they are on the same side. The same thing with this one. Okay? Now we're going to do what we did up here. We're going to multiply our coefficients, but if we have more than one exponent, we're going to add their exponents together. So from here, we're going to say this 5 times 7 gives us 35. Because they both have p, remember, they're both raised to the 1 power, so this p times this p gives us p squared. All right, we're going to do the same thing. This is a -7 times a +7, which gives us a -49. Only one of them has a p, so we're just going to bring that along. And then once I'm done multiplying this 7 by this 5 and this -7, I'm going to go to the bottom and I'm going to start multiplying these two numbers on the top by -2. So -2 times 5 gives us -10. Only one of them has a p, so bring it down. And then we're going to do -2 times -7, which gives us a positive 14. Notice that neither one of these has a p, so my answer will not have one either. Now, once you're looking at this, remember that up here in the previous problem that we did, not only did we multiply and get all our new coefficients, but then we had to look for like terms. And we noticed that these two right here had the same variable raised to the same exponent, which allowed us to put them together. We can actually do the same thing with this one. But because we're dealing with a box, I'm going to tell you that your diagonal in the box is going to be your like term. So this is my diagonal right here. And notice that those two numbers, the -49 has a p, and the -10 has a p. This one has a p squared, and this one doesn't have one at all. So that lets us know that these two are the only like terms. Because we're writing this in standard form, we're going to say 35p squared first, because it's the one with the biggest exponent. And then if you take a -49 and you subtract 10, it does give us a -59p. and then our constant is 14. So not only did we multiply, we were able to identify the like terms, we were able to put them together, and then we were able to write it in standard form. So this right here is our final answer. Now I'm going to change it up a little bit for the second example here, because notice that it is different. We have two terms in the first one. There's no plus or minus in the middle, so that automatically lets me know that I'm multiplying, not adding and subtracting. And then I have three terms. So that means I'm going to create two rows, but instead of two columns, I'm actually going to add an extra column for the extra number in the second parenthesis. So I'm actually going to write it a little bit smaller just to make sure it fits in. Remember to leave enough room on the sides because that's where we're going to write our numbers. And then here are my two rows, and then here are my three columns. So this is a 2 by 3. Now I'm going to take my two terms, which is the 6k minus 4, write them on the same side. And then we're going to take the second parentheses, we're going to take our three terms and write one on top of each column. So 7k to the second plus 2k minus 1. And you're going to notice that when I write this out, I use every single thing. All the numbers, the variables, the exponents, and even the signs to let you know if that's a positive or a negative number. So continue to use everything inside those parentheses. Now for this one, we're going to take the 6, we're going to multiply it by 7, by 2, by negative 1, and write it here. And then we're going to take this negative 4 and do the same thing. So I'm going to go through it, and we're going to say 6 times 7 is 42. Now pay attention to your k's. This one has 2. This one has 1. So if I multiply the k's, I actually have 3 in total. So we're adding them. All right, we have 6 times 2 is 12, a positive 12. 1k here, 1k here, so together they became 2. 6 times negative 1 is negative 6. This one doesn't have a k, but this one does, so they have 1 together. Now I'm done with the first part. We got to go ahead and multiply by negative 4. So we're looking at these numbers up here, and they're getting multiplied by negative 4. So negative 4 times 7 gives us negative 28. Bring down the k squared, because the negative 4 has nothing to add to it. Negative 4 times 2 is negative 8. Bring down your k. And then negative 4 times negative 1 is a positive 4. No k's. Now, when we did this one right here, we were able to see that both of these had like terms. That's no different in this 2 by 3. The only thing that's going to be different that's from the previous problem is that we have two diagonals. So if you look at this one right here, both of these have k squares. And then if you look at this one right here, both of these have k's. So the bigger your box gets, the more like terms you're going to have. So let's start with the highest exponent, which happens to be k to the third. There's nothing to combine with k to the third, so we bring down 42, k to the third. Now I do have both of these right here, so we're going to combine 12 minus 28, which will give us a negative 16k squared. And then right here we have two more like terms that need to go together. So we're going to take the negative 6, subtract the 8 from it, and that is going to give us negative 14k. And then we have this plus 4, which is our constant, nothing to combine with it, so we just bring it down. So not only did we organize our work, and we focused one on each term individually, but then we were able to identify those like terms, combine them, and then from there write it in standard form. And that's it. So this right here is our final answer. Now we do have two problems at the bottom that are considered our special polynomials, but I'm going to go ahead and throw them in the other video just so we don't have to rush through them. All right. I hope that these examples have helped. I hope you understand that using the box method is no different than using the distributive property. It's just a different way of organizing and looking at your work. So I will see you in the next video.